Hello everyone. Today I will review phase 2 of my Capstone project, which covers my exploratory data analysis and the progress made towards my model construction. As a quick review, the goal for this project is to determine if certain school-level features can predict a high school's proficiency performance on state assessments for reading and math. The overall methodology for this project will involve extracting, cleaning, and processing files from multiple data sources to generate master data sets that will be utilized for EDA and model constructions. Finally, models will be executed, evaluated, and utilized to generate final interpretations for this project. As reviewed earlier, this phase involved extracting data from various sources like the CCD data source, and each data source contained multiple files that were each cleaned, processed, and combined into a single source-specific data file. Finally, the source data files were merged sequentially to create two master data files, one for reading and one for math, that was then utilized for further exploration, analysis, and data modeling. Once the files were cleaned and combined, the Pearson correlation test was used to identify any existing relationship between the target and feature variables. The correlation revealed that there is a moderate positive correlation between the neighborhood income poverty ratio and the school's reading and math proficiency performance. Also, there are weak positive correlations between AP courses offered or taken by students at a school and the school's reading and math proficiency performance. Next, in preparation for the data modeling process, the data sets for reading and math were split into training and testing data sets. Then data transformations were applied and the features were standardized to improve the model's performance. Let's take a closer look at each of these steps. In this step, the data sets for both math and reading was split using an 80-20 ratio for the training and testing data set, and the features and target variables were separated from the train and test data sets and assigned new labels to facilitate the modeling process later. Next, one-hot encoding was applied to the categorical variables in the data set, and they were converted into a binary integer such as 0 or 1, which was then vectorized for each unique value, resulting in 6 additional columns added to each dataset. Lastly, several features within the dataset contain different scales and a high degree of variance. Thus, the features were standardized using a standard scaler to address this issue. Once the data was sufficiently transformed and prepped, I utilized a multilinear regression model for training and testing. I then looked at the coefficient of determination, or the R-squared value, to evaluate the variance in the target variable that can be explained by the feature variables. Based on these R-squared values, we can see that there is a great deal of variance present in both the math and the reading datasets. For phase 3, I will continue tuning the model to improve its performance, explore other models to compare how they perform, and then evaluate their performances. Finally, I will explore any other considerations to take into account in the future of this project. And this concludes my presentation. Thank you for listening and stay tuned for phase 3.